Hello. Today we are going to present our project Dynamic Dynasties Map of Indian History, which was made as a part of Database Systems Course CSCE 413813, School of Computing, University of Nebraska-Lincoln. I am Sai Vivek Putlapalli and my teammate is Bal Subramaniam Dugirala. Our project our project presentation consists of motivation and goals, design overviews, data sources, data transformations, implementation, conclusions, and future work. Since our project is about India and its ancient history, uh, I got a quote which attracted me in internet. It says, "India is a cradle of the human race, the birthplace of human speech, the mother of history, the grandmother of legends, and the great grandmother of tradition. Our most valuable and most constructive materials in the history of man are made up in India." Uh, it's quoted by Mark Twain when he visited India in 1857.
Vivek, let me just talk about the motivation and goals of our project. India is one of the most diverse countries in the world with hundreds of languages, tribes, and cultures. Although it had been the meeting ground between East and the West, no one dynasty could define India in its entirety, given its vast cultural diversity. As citizens of modern India, that's what defined us. That's what defined India with its 29 states representing unity in diversity. Um, we were wondering how our country took its present shape over centuries of invasions and rule of various dynasties. So, from this motivation, we have chosen our goal to represent a database system which can which can visually represent the maps of India, maps of different dynasties of India uh, over the centuries of time. So our goal here is to be able to visually represent different dynasties that have ruled over India over centuries, along with some historically significant data that's available to query. We also aim to characterize dynasties by adding information of various rulers that ruled over a particular dynasty in a given century. We try to find trends in the distribution of dynasties. For example, the area of the dynasty that remained intact over the centuries. What dynasty did a present day city belong to back in a given century, etc. For example, if we are talking about a city called Hyderabad, which we both belong to, our teammates, it was ruled over by multiple dynasties over multiple centuries. Um, just before the arrival of British in India, it was, I think, ruled by Nizam, but previously it was ruled by Kakatiyas and so many dynasties before that. So that kind of shaped today's Hyderabad in a very different way compared to other cities of our state, Andhra Pradesh. It's easily reflected in the culture of the people and the languages, the dialects Hyderabad has, and the uh, kind of kind of inspiration the movie industry gets in Hyderabad. There's a lot of things that influence Hyderabad, and that's a part and parcel of the impact of a lot of dynasties that ruled Hyderabad. So this is basically the ER diagram of our project, which represents different tables and their attributes. The main one here is the dynasties table, which has the ID. X and Y are the coordinates of the points present through the map. T is the time. And the name table represents the names of the dynasties which are present in the dynasties table. It has ID and name as attributes. We can notice that the ID column present in the name table is a foreign key of the dynasties table. We also have city and city names. Uh, a little detail of kings and their details is given in the kings table. We also have a table called India, which is used as a baseline to represent the India map on which different dynasties are represented. So that's about the year diagram. And the data sources are a little interesting here because um, we use a system called MLPQ system, and to be able to represent different maps on MLPQ system, which come from different sources. One obstacle we faced was to get them from uh, pictures of same scale. So it was hard to find pictures of Indian maps with different dynasties over time, which have the same scale too. Luckily, this YouTube video helped us to achieve that. And to get the king's information by dynasties and tenure, we kind of referred to this Harvard's history department's website, and of course Wikipedia. So the map constraints, the visual representation, which we will be seeing shortly on the MLPQ system, was done by clicking over various maps. And this script i2v2c.m MATLAB script is which helped us to get that done. And of course, the whole project is based on the MLPQ system because it's super efficient and made our work very easy. So these are the raw images which we got from that YouTube video, which represents India from first century to 1700 CE. As you can see, the map has been changing consistently over every 100 years. And this is what we wanted to represent in our database, and basically let users query and get a little more information other than visual representation too from the MLPQ system.
As my teammate Bala explained the data sources, so the data grabbed from those sources were tuned into these different tables, which you can see in the data transformations page. So as the ER diagram explains, we got the dynasties table with ID X Y T as it attributes. So IDs are different for different dynasties, and as we selected 15 dynasties, we got 15 different IDs. So T represents the time in centuries, and XY are the coordinates of the map. So it goes same with the India table, which is going to be represented as a map, and the cities table, the ID represent different cities. XY are the coordinates of the map, and time T is the time. So the name table contains ID, which is a foreign key of dynasties and kings, and the dynasty name. The name table here joins the dynasty with its name by using ID as a foreign key. And also with the king table, the ID in king's table um, is also a foreign key of dynasties and name table. So name represents the king name, and from to represents the king's tenure. So these are the dynasties which we have chosen. Like we have chosen 15 dynasties. There are a lot more, but restricted to this timestamps and stuff. So we had to choose 15 dynasties. These are pretty much the dynasties: Chola, Kalinga, Satavahana, Madura, Andhra Bhartiya, Gurjara, Pradihara, Pala, Gupta. These are different dynasties which have we used as a part of this project. So it's not like every dynasty has been there on the map throughout the 17th centuries, which we have got the data. So uh, just like I've said, the Kalinga dynasty has been present from the 1st to 10th century, whereas the Chola dynasty is active from the 0th to 3rd century, and uh, in 4th, 5th, 6th, 7th, 8th, Chola dynasty was never there, and it reappeared in 9th until 11th century. So as are the dynasties: Chalukya, Pallava, Vijayanagara, Delhi Sultanate, Mughal Empire, Kakatiya, Yadava. These are the other dynasties which have chosen as a part of this project. So let's get to some interesting SQL queries. Yeah. So the problem here is to find the part of India ruled by Delhi Sultanate in the year 1300. Um, so this is a basic SQL query which I've selected the coordinates on the map from dynasties and name table. With the idea of join both the tables and search with the dynasty name Delhi Sultanate, and time will be 1300. So here's a map which represents Delhi Sultanate Delhi Sultanate's area over India. So the green color here on the map represents the area which was ruled by Delhi Sultanate in the year 1300, and orange color is the outline of India map. Coming to the second query, we wanted to find the total number of kings who ruled under different dynasties. So as the query says, we have selected the dynasty name and count of kings from kings and name table. We have joined it by ID and grouped by dynasty name. So as you see in the solution, we got 21 kings under Pala dynasty, 22 kings under Chola dynasty, and so on. So this is another interesting query which we thought to find the tenure of kings who have ruled over the years. So the query says it selects king name, dynasty name, and length, which we have. Length is the difference between to and from the king's table. Like it will subtract um, to from as a part of king's table, and it gives a length. Length here means the tenure of king in years. So yeah, so these are the kings who have Vijayalaya king of Chola dynasty ruled over 23 years, Aditya I ruled 36 years, and so on. Bala, can you take over from here?
Yes, Vivek. So the problem which is being addressed here is finding the part of, for example, a dynasty, Gupta here in this instance, that remain unchanged through unchanged through a number of centuries. Basically, there is a lot going on if you're talking about ancient kingdoms and all these things, and wars or consistency. So you never know when the face of the map is going to change. So there are some parts of the map, of the territory, which are retained by the emperors even after the wars, and even after a lot of political changes might happen, and that's what we are trying to find out here. This in this instance, we are trying to find the area of the Gupta dynasty. Find the visual representation of Gupta dynasty that remain unchanged through fifth and sixth centuries. In order to do that, we have a very handy function present in MLPQ, which is MLPQ intersect. All we had to do was select the representation of Gupta dynasty. Select the area of Gupta dynasty as a query from the 5th century, and select the area of the Gupta dynasty from the 6th century. After selecting both of them, a simple press of a button in MLPQ intersect will give us the area that remained common between these two queries. Here, the red colored map represents the Gupta dynasty in 5th century, and the yellow colored one represents it in the 6th century. And the third map, as you can see, the orange colored intersection is the one which represents the area that remained unchanged. So another interesting problem here is to find the dynasties to which modern cities of India belong to in the first century, or any given century for that matter. Um, it's always interesting to know the current modern cities which we live in uh, have gone through a lot of rule and change of empires and whatnot. So what we wanted to do here, given our rich database which has data from various centuries, is to find out at a given point of time what is the empire that ruled over a particular city. Um, the motivation behind this is to find out all the impacts that the city might have faced that let it take its shape in the present day. Um, in our database, we only had 5 cities as a working model, that is Chennai, Mumbai, Hyderabad, New Delhi, and Kolkata. And here, what we are trying to do is we are trying to find the dynasty name to which the modern city belonged to back in a given century. Let's say the first century here. All we had to do was create a dynasty's view, select the city name and the dynasty name from our dynasty's table. The name tables which you are looking at are just used for fetching the names of the particular dynasties and the cities. Uh, what we had to do was we had to kind of make the maps intersect. I mean, we have a map of the city as well as we have a map of the dynasty. If we are trying to find the common area uh, during a given time, we will get our answer, because the location of the city is constant and it doesn't change, but the dynasty might change. That's the idea here. And this is the problem where we find the area of a given dynasty in a given century. This is a straightforward query uh, where we can find out across how many square units the empire was spread, and things like that. Um, in this area too, MLPQ helped us by bringing in a handy function, that is MLPQ area. All we had to do was select the coordinates of the dynasty which we are looking for, and on click of a button, we will simply get the area. The minx and maxx you're looking at are the range of the horizontal space. I mean, um, if you let's say if you don't want the area of the whole map, and if you just want the area between the x coordinate 500 and the x coordinate 1500, this is where you specify the input. So this will give the area between those two specific horizontal points.
So here we got the area of Chola in 11th century to be 25,822 something square units. So
Yes.
these another interesting query which we have implemented using the MLPQ system.
Okay, let's talk about conclusions and future work. um, the idea with this project is to be able to visually represent the um, different dynasties of India over a period of time. Of course, since this is the beginning of the project, we only included 15 different dynasties, but in fact there are much more dynasties which are yet to be included in the project. And also, along with dynasties come a lot of rich data which can be incorporated into the project, which might lead to a lot of information that might be useful to, let's say, historians or just any history enthusiasts. So this can be basically added by extended by adding all other dynasties to create a rich source of historical information about India. Um, we can add details. By details I mean details about the rulers, the capital cities of the dynasties, historical monuments, let's say Charminar from Hyderabad, or Taj Mahal from New Delhi, the wars that were fought, that um that influenced the dynasties. uh, and also, I think since we represented only till about 17th century or something like that in this project, uh, after that is when the British advent begins in India. And it will be interesting to see how these different dynasties fell into British's rule, and that kind of had its own influence basically on the modern day India as well. So as the time progresses towards the present from the past, we can easily correlate the culture which is being enjoyed in India to whatever rule it had faced from different dynasties and the British rule and other things, and it will be an interesting thing to query for.
Yeah,
So
and also when we say India, uh, we say yeah, India's got unity in diversity. So where did India get this diversity from? It's definitely from its rulers who have ruled India over the past
exactly,
500, 600, 1000, 1500 years. So
yeah,
each ruler and each dynasty has brought something to India. Maybe language, maybe traditions, maybe some cultural changes, maybe some political impacts. All this stuff can be added to this project and make this project more interesting. So that's it about this project, and thank you.